At this point, we've already done 5-1B and 5-1C for the most part. So let's go ahead and take care of 5-1A. So domain for all exponential functions is what? Okay, negative infinity to positive infinity, right? Okay, so for our domain, we have negative infinity to positive infinity. Now, when we graph this, is it going to be facing up or down? Oh, it's going from down to up. So it's going to be facing downwards. Okay, so let's graph it really quick just to kind of look at it. Okay, so when we graph this, we're going to have negative 3 times 2 raised to the x plus 3. So it's going to look like this. I can pull up the table, and I can fill this table in on my paper. So if you don't have that table filled in, take a moment, write this down. So range is going to be from negative infinity to 3. Negative infinity to 3. Because if we look at our graph, our y values go from down here all the way up to 3. 3 is our asymptote. Okay, and that answers the next question. What is our asymptote? And that is 3. Y equals 3. Where does it have a y-intercept? And if we look at when x is 0, what's our y? 0. So we're going to write that as an ordered pair, which is 0, 0. The x-intercept is where it crosses the x-axis. Okay, so we can look at our table. Does it cross the x-axis? Yes, it does. Where does it cross at? 0, 0. Again, it's okay for you to have the y-intercept and the x-intercept be the same. All right, so true or false? The function is decreasing for all real numbers. True. That's true. Are there any questions on A through F? Okay. Now, on G, it says as x decreases, what is y doing? Where is it getting closer and closer to? So as we move to the left, what's happening to our y values? They stay the same. They're going to what number? 3. Or another way to say this is increases to 3. So as we move to the right, what happens to our y values? Where do they go? They go decreasing. Are there any questions on G and H? Okay, positive and negative. That means that it's above the x-axis and below the x-axis. So positive means we're above. So when is it above the x-axis? Well, when we look here, we see that it's above the x-axis until 0, 0. And then it's below. So we're going to say, using our domain, we're going to say from negative infinity to 0, 0. And then from 0, to positive infinity is when it's negative. Average rate of change, also known as AROC, also known as slope. That's y2 minus y1 over x2 minus x1. When they give you an interval, that's going to be your x1, x2. So this is going to be your x1, x2. Now, in order to figure out your y1, y2, you're going to go to the table and look at when x is those numbers, what's y? So when x was 0, what was our y value? 0. So we have the point 0, 0. And then 2, what was our y value? When x was 2, what was our y value? Negative 9. So this is our x1, y1, and our x2, y2. So now we're going to plug that in. Negative 9 minus 0 over 2 minus 0. So that's going to be negative 9 over 2, which is negative 4.5, or you can just keep it in a fraction. There will be an average rate of change question on your test. No. That's tough. No educated guesses. Okay, are we decaying or growing on the next one? Decaying. Look at the y values, they're going down. What is the growth or decay factor? Okay, so first, remember, our exponential function is this. What's our initial value? Oh, sorry. I'm so sorry. I know the wrong thing. 3. And what are we going down by each time? Divided by 3. Another way to say that is to multiply by 1/3. What is the number inside the parentheses? 1/3. 1/3. That is the decay factor. Now the y-intercept is 0, 3. I'll give you a second to catch up. Where's the x-intercept? Can we tell? Let me ask you this question. If I took 1/3 and I divided it by 3 again, that would give me what? 1/9? And if we divided it by 3 again, we would get like 1/27. And if we divided by 3 again, we would get, and we would just continue on, right? Now, will that ever actually hit 0? No, because we can always divide by that number. So there is no x-intercept. Is it increasing or decreasing? Decreasing. And then we want to write the equation. Well, we already talked about it. 3 times 1/3 raised to the x. Average rate of change. We got x1, x2, and y1, y2. And we're going to plug in. And so that's going to give me negative 8 divided by 2, which is negative 4. All right. So you should have gotten 4 and 24. Okay. Organization C is going to go up more quickly. It's a little bit steeper. Okay. We also see that it's linear for the first organization. And then the second one, it's exponential. And what does this tell you about the number of donations collected by the two organizations? So basically, organization C is going to have 24 donations over the span. I'm sorry. It's going to go up 24 over 1 over the span of 0 to 6 hours. Okay, so for every hour, it's going to have at least 24 given. So down here. And then on the other one, 4 were given each hour. Okay. Less steep is over here, more steep is over here. When we talk about steepness, we're talking about it increasing more rapidly. Okay, so B is 5/7, D is 0.99, and then 1.01, and then 1.4, and then 4. We notice how the B value is what was important. So looking at these, the B value is what was important. Everybody see that? The higher the number is, the more steep it's going to be. Okay, so when we write the equation, we're going to use our y-intercept. Okay, so what is our y-intercept? 1,000. Okay, and then we're going to find the rate. Here's how you find the rate. Ready? If you take the second and divide it by the first, 600 divided by 1,000 is going to give me 0.6. You have to make sure that it works for the next thing though. So for instance, if I took 600 and I multiplied it times 0.6, would that give me 360? Yes. Okay. If I took 360 and I multiplied it times 0.6, would that give me 216? And the answer is yes. So 0.6 is my rate, and then we're going to raise it to the n. This doesn't always work because sometimes there is a transformation that occurs that's like add an asymptote or whatever. Okay, so just keep that in mind. All right, the table shows the amount of money a retirement plan receives for each year. How much money does a retirement plan receive in year 4? Okay, so we got to figure out what the rate is. So we're going to take the second and divide it by the first. And when we do that, we're going to get 1.1. Again, we want to make sure that that's right. And it is. So if I took 24,200 and multiplied it times 1.1, this would give me 26,620. And then if I multiplied it again, I'm going to get 29,282. So 29,282. Which equation that models this retirement plan? What was my initial? 20,000, right? And then what was my rate? 1.1, and we're going to raise it to the x.